What's up, everyone? This is my explanation of threesome, the threesome problem on LeetCode. So I've seen a lot of confusion surrounding this problem, and I want to just like explain a few things because it's really not that difficult, I feel like, and it kind of seems more difficult than it needs to be because there's a lot going on with the pointers. But really, what this problem is it's just a variation of two-sum integer 2, which is basically just two-sum when the array is sorted. So in this problem, you need to initiate two pointers, a left and a right, and the left goes at index 0, the right goes at the len nums -1, and then you pretty much just, every time you sum two pairs of a pair of two numbers, you compare that to the target, and if it's greater than the target, then you move the right pointer to the left, and if it's less than the target, you move the left pointer to the right. If it's equal, then you just return, right? So in this case, we have 1 and 4. 1 plus 4 equals 5, which is greater than 3, so we move 4 to the left. 1 plus 3 is 4, so we move, which is greater than 3, so we move this to the left. 1 plus 2 is 3, so that equals the target, so we return. The same thing is going on here. The only difference is the first for loop, because obviously we have three numbers now that we worry about, so we need another for loop here that's going to account for that number, and we also need to avoid the duplicate. So we keep continuing, basically, if we're not at index 0, we keep continuing if nums I lands on a duplicate, right? So if like I is here, this is going to continue this iteration because I was previously -1, and it's going to be 0. We keep doing this because we don't want, right? We don't want the same output over and over again. The same thing happens here. You notice how the inner loop is basically very similar to this solution. The only difference really is the bottom part. The reason why we need the bottom part is we're not terminating this loop, right? So like in this case, we find there's exactly one valid solution, but in this case, there could be multiple. So we need to adjust the k pointer is always going to be the same when we start, and so is j. But the biggest hurdle is to adjust the j pointer to avoid duplicates, because once we, like, let's say j, we have I, the first iteration is 4, and then j is here, and then k is here. Well, the second iteration is going to be i's here, j's here, and k is here, which is our first answer. -1 plus -1 plus 2, which is 0. Imagine like we have another -1, and we append that into the array, right? We append our first answer, this one. I is still going to be here. The loop does not terminate once we find an answer. The loop terminates when j equals k. So when the j pointer is here still, it's going to move here, and guess what? We're going to get the same thing, -1 plus -1 plus 2, because 2 didn't move. The only thing that moved is j, because we incremented j plus 1. So that's why we have this while loop here, because once we increment j to the next number, it's going to keep incrementing until we hit a number that's not a duplicate, which is 0. So then it will be -1 plus 0 plus 2. And then we just keep on doing that until we reach j, when j equals k, essentially, because that pretty much means that we're done, that we didn't find anything. So that's why we need this part, is we basically need to find there are multiple answers. Like, that's the point, is that this one was just like one valid solution. This one, that's not the case. So we need to do this little fancy part at the end to find the right solution. But in this case, obviously, like that, in the test case given on LeetCode.io, that's not what's going on here, but you know what I mean, right? Like, if you're iterating through this, The same thing is for I. Like we need to avoid landing on -1 again. So after we're on -1, I is going to continue until we reach 0, pretty much, right? And why does that happen? Well, again, it's really it's the same reason. So yeah.